to work 3 questions together because 8 and 9 relate back to question 7. So we'll go over, first of all, finding the determinant. And the easy way to find a determinant, or the way to do it, is it's going to be a cross multiplication and then a subtraction. So we go from the top left to the bottom, so that's -1 times -2 minus -1 times +2. So a determinant is always going to be equal to a single number, just one number. And so that's going to be +2 minus -2. You add those together, so plus, that becomes a plus, so our answer is 4 here. Okay, we'll come back and do the calculator version all at the same time. Again, the determinant 5 times 0 minus 0 times -1. We get 0 minus 0, which is 0. I'll box that one because if I circle it, it'll look like 2 circles. So the determinant here is 0. 3 by 3. We won't even try this by hand. It involves a lot of work. And so if we need to get this, we go definitely to the calculator. So we'll do this one, and then we'll go back and check the answers to the other ones. You can do it that way as well. Oops, let's see, nope. Let's get matrix. So let's come matrix B. Oops, we're going to edit matrix B. It is a 3 by 3. And incidentally, you can only get a determinant for square matrices. So -2, 5, -2, -1, 1, 0, -3, -2, 2. So make sure we got it all entered in correctly. And then what we're going to do the determinant, we have to get to the main calculating screen. We'll just clear everything out. We go to matrix again. We pull up the determinant, DET. That's what that first one is. And then we put that matrix that we just entered, matrix B. That's what we want the determinant of. And so the answer there is -4. So I would come here, just put equals -4. And again, they can use lines like, I guess if this was matrix A, you could say, it looks like absolute value, but in terms of a matrix, that means a determinant. Let me just do one of these quickly. Actually, maybe do both of them. Come back to matrix. Let's enter the first one here in C. Oops, no. To enter it, you have to go to edit, edit C, and it's a 2 by 2, because we're going to need this for the next part anyway. -1, 2, -1, -2. Let's make sure negative, 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 positive. Okay, so that's matrix A. We quit, back to matrix, and then let's put the next one in here. Oops, here, edit, and that's a 2 by 2. And we put in 5, -1, 0, 0. Okay, so we got all our matrices in there. We just maybe make a note of which one's where. And to get the determinant, we go matrix, math, determinant, and I'll just show you that matrix A, which I have stored here as matrix C. should give us the determinants 4. Okay, so you could do that to check. You could do it, but just know how to sort of do this cross with only a 2x2 matrix. Anything larger, it's just too much work, and there's going to be too many errors. You'll see you could do the same thing here, but what I want to do is actually I want to pull up. Let's go. I think I did have the answers up here, don't I? Yeah. So the determinant 4, 0, and negative 4. So those answers match the answer in the back. They want us for each matrix in problem 7 to state if an inverse exists, and then if it does, to find the inverse. So actually we'll do 8 and 9 together simply by finding the inverse. Now the inverse is this key. As you know, we've been going second matrix, but if we don't do a second, that's the inverse key. X to the minus 1, that's an inverse. So all we have to do is go get the matrix, and again I think it was in C. So this first one, A, I've got stored in C. To get its inverse, I just hit this. Now if there's not an inverse, it'll tell me an error, but this one does have an inverse. Yeah, I want it in fractions, right? If maybe because it looks nicer, I could stick with this, but let me pull this back up, and remember I can go math and just give it to me as fractions. Maybe it looks a little prettier, so I could, and this will match the answers they have in the back of the review as well, as they give them in fractional form. So A, its inverse is negative 1/2, 1/4, negative 1/2, negative 1/4. You will not have to be able to manually find the inverse of a matrix. And again, because it just becomes more and more complicated, and we want to use our tools. B is a good one. Again, the reason we have you already having everything entered in is now we just go do the inverse of B, a big part which we stored down here in D, right? That's where I put it. To find its inverse, I go there. Oops, but it's a singular matrix, so that's kind of cool. It even tells me what it is. It's not, not only does it not exist, it's a singular. So I would say, I don't know, in our other stuff we do what D and E does not exist, however. And then finally C, again, definitely want to use this tool. So if once this happens, I have to hit enter to quit this. Let's just clear out everything so we have room for everything, and then we pull up our matrix, which is a 3x3, is it stored in B, and then to do the inverse we just put that, and it gives it to us. Again, I forgot, actually you could just go math fraction, and it takes the answer and turns it into fractions. So then you could write all that out. I could, but I'll leave that showing there, and we'll click one more time here and get the answers, and you can see that is the same answers we got there, same answers we got here, and that there is no inverse for B. Another way to know that there would not be an inverse, there's never an inverse if the determinant is 0. Okay, so if you see a 0 determinant, you know there's not going to be an inverse. Okay, so that's good. But we can find the inverse also if you just plug it in and try to find the inverse. It'll tell you if there's no inverse, it'll give you that error message. Otherwise, it will give you the inverse. And that's all we need to do so far with that part.